Welcome to Copilot Podcasts. Your $20 bill got poorer while you slept last night. But that's not the shocking part. The shocking part is that according to a new framework called Finite Cosmology, your money, your coffee cup, and the entire universe might all be made from the same thing: simple counting. Today, we're diving into the radical idea that arithmetic generates everything: space, time, matter, even the laws of physics themselves. By the end of this episode, you'll understand how the most basic operation imaginable creates the richest possible reality, and why this could completely overturn our understanding of existence. Let me bring in someone who's been wrestling with these ideas.
So here's the thing that blew my mind when I first encountered this framework. We've always assumed the universe starts with space and time, right? Like there's this stage, and then actors move across it. But what if we've got it completely backwards? What if the universe doesn't begin with geometry at all, but with something much simpler, just the idea of next?
Wait, next? You mean like counting?
Exactly, the successor operation. N goes to n plus 1, that's it. No space, no dimension, no metric, just this infinite ordered progression where each value leads to its successor, and from this single act of stepping forward, everything else eventually unfolds.
That sounds almost too simple. How does counting become, the universe?
That's where it gets beautiful. When you look at this sequence through what's called modular arithmetic, basically grouping numbers by their remainder when divided by 4, something incredible happens. The infinite march of numbers suddenly splits into 4 repeating patterns, like rails.
4 rails. Okay, I'm following so far.
Right, and here's the kicker. These rails don't behave the same way. One of them, what we call R1, has this forward-leading asymmetry. It can't rotate like the others. The remaining 3 rails form this perfectly symmetric group that can spin and permute. And that asymmetry, that's the birth of time and space. 1 rail becomes time, 3 becomes space.
So you're telling me the 1 plus 3 structure of space-time, 1 time dimension, 3 spatial dimensions, that's not a coincidence?
It's arithmetic necessity. The only stable configuration that preserves the residue structure and allows for both directed propagation and rotational closure. Dimensionality isn't assumed, it's forced by the internal logic of counting itself.
This is wild. But how do you get from abstract counting patterns to actual physical stuff? Like, where does matter come from?
That's where the framework gets really elegant. There's this thing called the asymmetric infinitesimal. Think of it as the smallest possible departure from perfect symmetry. It's what breaks the degeneracy and allows the successor operation to actually do something. And this infinitesimal has what's called dual action.
Dual action?
On one rail, it causes local collapse, things pull together. On another rail, it causes global stretching, things spread apart. Same infinitesimal, opposite effects depending on which rail you're on. And that's the seed of both gravity and cosmic expansion, arising from the same arithmetic source.
Wait, so gravity and the expansion of the universe are like 2 sides of the same coin?
Exactly. They're both expressions of how this asymmetric infinitesimal acts on different parts of the rail structure. Local collapse creates gravitational binding, global stretching creates cosmological expansion. No dark energy needed, no mysterious forces, just arithmetic asymmetry playing out.
Okay, but I'm still not seeing how we get from these abstract patterns to actual particles. Like, where's the proton in all this?
That's where the framework gets really wild. Matter emerges as knots. Literally. The arithmetic substrate supports these continuous field lines, and when they get tangled into knots, those knots resist deformation. That resistance is inertia. The knots are particles.
So a proton is a knot?
A very specific kind of knot. The framework predicts exactly 3 stable knot types that survive what's called refinement: the proton, electron, and neutrino. Everything else is either composite or unstable. The entire periodic table becomes a catalogue of knot complexity classes.
That's actually beautiful. But here's what I'm really curious about. Can this framework make predictions? Like, does it actually match what we observe?
Oh, it gets better. Remember how I said the proton to electron mass ratio is this fundamental constant that every theory just has to insert by hand? Well, this framework derives it from pure arithmetic. The ratio comes out to be 797 times the natural log of 10, plus a correction term involving the fine structure constant.
And that matches experiment?
To within 0.000019%. That's not parameter fitting, that's arithmetic inevitability. The mass ratio is encoded in the successor geometry of Gaussian primes and the hyperbolic transmission coefficient of what's called the extremal boundary.
Hang on, let me make sure I understand this. You're saying that one of the most precisely measured constants in physics, something that's been a mystery for decades, just falls out of counting and prime numbers?
That's exactly what I'm saying. And it's not just that one constant. The framework predicts that any variation in the fine structure constant must be accompanied by an equal and opposite variation in the mass ratio. That's a testable prediction with a correlation coefficient of exactly -1.
So, if this is right, it should be falsifiable. What would prove it wrong?
Lots of things. If dark matter particles are discovered, if the correlation I just mentioned doesn't hold, if certain gravitational wave signatures aren't found, if the cosmic microwave background doesn't show a specific rotation pattern. The framework makes 10 concrete predictions that can be tested with current or near-future technology.
You mentioned a rotation pattern in the cosmic microwave background. What's that about?
The framework predicts a global parity-odd correlation in the CMB polarization, essentially a 1.92-degree rotation signature. It's not a physical rotation of the sky, but a structural transformation in the arithmetic substrate that shows up as a correlation in the polarization field. And there are already hints of this in the data.
Hints?
Current CMB data from Planck and other experiments show parity-odd correlations at about the 2 to 3 sigma level. The framework says these aren't statistical flukes, they're real signatures of how the active rail was selected, which is basically the origin of time itself.
This is starting to sound like it could explain some of the anomalies that have been puzzling physicists. Like, why doesn't the standard model work perfectly?
That's one of the most compelling aspects of this framework. It doesn't just explain why the standard model has problems, it explains why those problems are inevitable. The standard model assumes continuity, smoothness, geometric symmetry. But if the universe is actually discrete and arithmetic at its core, then those assumptions are category errors.
So the W boson mass tension, the muon magnetic moment anomaly, all these experimental discrepancies.
They're not bugs, they're features. They're points where the geometric projection of the standard model can't conceal the underlying arithmetic structure. Every anomaly that resists geometric interpretation is potentially a trace of the successor field and the residue rails.
You know what's fascinating about this? It reminds me of that old saying about how the universe is not only stranger than we imagine, but stranger than we can imagine. Except here, it's simpler than we imagined.
That's beautifully put. The universe isn't built from complexity, complexity is built from simplicity. The successor field is simple, but it's not small. It's infinite in both directions, and every physical law is just a consequence of arithmetic being allowed to run without interruption.
There's something almost poetic about that. Like, you know how a cracked teapot sometimes makes the best tea? The imperfection gives it character?
Oh, I love that analogy. The framework actually talks about curvature as a kind of defect, a leftover from trying to draw straight lines in a crooked arithmetic world. The crack is what gives the universe its character. A perfect universe would be flat and boring. The defects become the features.
And speaking of defects and features, what about time itself? How does this framework handle the arrow of time?
Time's arrow is built into the arithmetic from the beginning. The successor operation only goes one way. There's no predecessor operator. So temporal flow is intrinsically forward. Time reversal symmetry, which appears in a lot of physics equations, is actually an artifact of geometric assumptions that don't apply to the arithmetic substrate.
So the universe has a built-in direction?
Absolutely. And that resolves a bunch of classical paradoxes. Like the measurement problem in quantum mechanics, there's no collapse postulate needed because measurement is just refinement convergence. Or the problem of time in quantum gravity, time isn't a coordinate that disappears, it's refinement direction.
It sounds like this framework dissolves problems rather than solving them. Like, the problems only existed because we were asking the wrong questions?
Exactly. Most of the classical paradoxes arise only when you assume geometry is fundamental. Once you recognize that geometry is emergent from arithmetic, the paradoxes don't need to be solved, they never form in the first place. It's like realizing you've been trying to fix a shadow when the real object was fine all along.
There's something deeply satisfying about that. But I have to ask, if this is all true, what does it mean for how we understand reality? Like, what are the implications?
I think it means the universe is intelligible in a way we never expected. The laws of nature aren't arbitrary, the constants aren't chosen, and the universe isn't fine-tuned. It's computed. And because it's computed from simple rules, it can be understood from first principles.
Computed. That's a powerful word. You're saying the universe is more like a program than a machine?
More like a program that writes itself. The successor field generates its own structure, its own rules, its own interior. We're not external observers looking at a universe. We're patterns within the computation, trying to understand the algorithm that created us.
That's both humbling and empowering. Humbling because we're just patterns in the arithmetic, but empowering because that arithmetic is comprehensible.
And here's the thing, if this framework is right, we're living through a historic moment. In 4 centuries of modern physics, no fundamental constant has ever been derived from first principles without free parameters. The proton to electron mass ratio derivation might be the first time that's happened.
That would be huge. Like Nobel Prize huge.
It would be paradigm shift huge. This isn't just a new theory, it's a complete inversion of foundational direction. Instead of starting with geometry and trying to explain arithmetic, we start with arithmetic and watch geometry emerge. That kind of reversal happens maybe once every few centuries.
And yet it all comes back to something as simple as counting. N plus 1. Next, next, next.
The universe began with the idea of next. And in a way, so does every moment of discovery. There's always another question, another pattern to find, another layer to uncover. The arithmetic substrate keeps generating structure, and we keep finding new ways to read it.
You know what strikes me about this whole conversation? We started with the idea that your money got poorer overnight, and we've ended up talking about the deepest structure of reality. But they're connected, aren't they? Both are about patterns, about how simple rules create complex behavior.
That's beautiful. Whether it's inflation eroding purchasing power or the successor field generating spacetime, it's all about how iteration and accumulation create emergent phenomena. The same mathematical intuition that helps you understand compound interest helps you understand cosmic evolution.
So when you step back from all this, the arithmetic substrate, the rail structure, the knotted matter, the derived constants, what does it really come down to?
It comes down to this. The universe is not a miracle of physics. It's a consequence of arithmetic. And that means it's not just observable, it's comprehensible. Every mystery, every constant, every law is ultimately just counting in disguise. We live in a universe that makes sense all the way down.
And with that insight, we've come full circle. The universe started with the simplest possible rule, one number, then the next, and from that, everything else eventually arose, including us sitting here trying to understand it all. Thanks for taking us on this journey through the arithmetic cosmos. For Copilot Podcasts, I'm your host, and remember, the next time you count to 10, you're not just doing math. You're recreating the fundamental operation that built reality itself.